Hello guys, and welcome to this channel. My name is Roman Narvaez. I am a civil engineer with a specialization in structural engineering. I am sending this workshop from the city of Gothenburg here in Sweden. We are going to go through a real building through some steps about performing a structural engineering project. And we are going to look at some points, blue points, about thinking how to deal with these kind of projects. Okay, in the next step we see the 6 point that I am told you to for this presentation. The environment, of course. I'm going to go through the geometry, the materials of this kind of project, the base loads that I am using for this building, the load combinations, and of course, finally, construction elements. The environment. Of course, the structural engineer has to do with the mechanical engineers, with electrical engineers as well, with building development, civil engineer, architects and project managers and customers and so on and so on. I put some few issues here, like for example in electrical engineering with that discipline, because we are working in a project with several disciplines. We are working with electrical engineers. We don't need to have deep knowledge about this stuff, but quite enough that you can deal with this kind of specialization. And this is things like, for example, the loads, anticipated electrical loads, incoming services and space requirements for volts and substations. They influence a lot of the building in terms of space. For example, the power distribution, there are points or sections or places where you put this stuff, and you need to know where is this. Electrical closets, communication rooms, embedded circuits, for example. Light fixture selection, it could be very heavy things. Switching controls from energy efficiency. There are some kind of boxes that you need to take care about that. Telecommunications and data systems, fire alarm systems, public address systems. That is for this specialization. We take some issues for the mechanical engineers, and of course the natural ventilation, where this stuff is going through, the position. We need to coordinate with these guys. Heat and cool plants, size of the equipment, of course, I told you before in electrical, is the same in mechanical issues. The size of the equipments, of course. The HVAC systems, wall and roof constructions, very important. Energy analysis, glazing requirements, room temperature, humidity levels, major ducts and pipes, of course, size of mechanical equipment, plumbing fixtures and controls. For our staff, structural engineers, we need to make this coordination as structural engineers. For example, with architectural design for multi-story buildings with steel frames. In our case, I am going to deal with 2-story building, which is the school. We need to think about floor grids, the position of this, to find some kind of coordination with other specialties. Influence of building heights, horizontal coordination. I'm going to talk about that later. Vertical coordination in terms of floor-to-floor heights, clearance for this stuff like electrical stuff or mechanical stuff. It's very important. For us as a structural engineers, we are responsible for the height of the different floors. vertical coordination in terms of structural zones. For example, the stability, we need to think about the stability, global stability and local stability. Service zones for this stuff, electrical and mechanical. The horizontal structural options that we have, of course, like services. The span range of structural systems, crucial for the amount of material that is going to deal with this building, and the benefits of long span construction. And we need to make some kind of appreciation for steel quantities for cost, calculating the budget and things like that. Right. So to take a real building here, I'm going to open the school that I'm talking about. Here we have a geometry. This building, I think it's on the short side is 30 meters, and the long side is around 100 meters. Here we have different kind of materials. Namely, we have on the ground, we have the flat slab on the ground, which is concrete slab. In situ, you have the beams on the ground, and that is the first floor. You have in the first floor the steel frame as well. You have trusses in steel. You have prefab trusses, and you have design trusses on the second floor. So the roof on the second floor is not prefab trusses. But you have a slab here which is timber, and for this stuff you have, for example, timber beams. They make this building lighter because if you have, for example, on the second floor concrete slab, you have a much heavy construction, and this will influence the foundations, of course. Yes, so they are the three here materials: concrete, steel, and timber. We are talking about the construction elements as well, and the construction elements here, as you see, we have on the ground ground beams and foundations and the concrete slab. We have the steel frame with the steel columns, the most of them. We have as well in some places here, for example, we have stabilization construction elements. Of course, on the other area around, under the second floor, we have stabilization. And we have stabilization on the long spans place of the building. You see there is stabilization. Yes, we have timber beams on the roof for the building, and so on. We can look at the foundation like that. Concrete. This is a building that you have the concrete slab with the foundation on a very good ground. Right. So we were talking about this stuff, materials, geometry, environments, and to talk about the base loads, load combination, and things like that, I'm going to go to the calculation tool. In my case, the calculation tool that I am using right now is I think so. I need to open, of course. Until this is open, we can look at a little more for this building. It's coming. So some patience is very good. So the building is coming, and of course, before detailing, I have done the building here. Here is the isometric view of the building. We have the east view or the long side view. We have the south view here. Of course, get back to plan view we need as well, and there is the geometry that you need to take care about if you are going to make sketches at the beginning about this geometry. Okay, so to see here, for example, the loads that we are talking about, you need to take care about what kind of loads you are going to use for this building. I would like to translate this because these loads are right now in the Swedish language, so I will translate to English. And I have here the self-weight, I have the snow weight, I have installations, loads and roof loads, of course, some kind of loads for extra considerations. I have the live load, the wind load in the X and Y direction, and some other stuff here. For these base loads, we need to make a load combination, of course, and take care about two states of calculations. One is the ultimate state, and the other one is the serviceability state. And on this building, I am using 15 load combinations. To see these construction elements on the calculation tool, we have the cover to have a clear, a crispy view of that one. I changed the view for another one here, so we can see some elements here. In the south view, you see that the steel columns, they are going to reach the roof, and on the long side we have columns, steel columns, the hallway. We have trusses, we have stabilization elements as well, and of course that was on the first floor, and the second floor, which is a slab here, but this is constructed with timber beams. So the next step after you have this model is to make an analysis about this, which it would be a later workshop. And after that one, it comes the detail design. And the detail design, I'm going to show things like, for example, we see here the position of the columns, the position of the ground construction elements, the different system lines, the serviceability zones, the structural zones, for bracing, for example, for services around what equipments they are going to use. So, and of course, in the detail phase, we can see the second floor here. Here is the second floor. So very good to have a very good knowledge about or manage of the system lines, because there's a lot of information that you need to design here. I'm going later on to discuss which are the responsibilities of the calculation engineer versus the responsibilities of the design engineer. Right. Maybe I will show you some details about this stuff. For example, I'm going to look at the detail drawing. All right, it's a lot of things. I hope that I found this. No, we have here, for example, the detail of the roof connections, system lines, details of the roof and the different parts. If you see, for example, the sections of this building for the south elevation, how you need to consider, how you need to construct this stuff. In the middle of the building, you have the concrete slab on the ground. You have the first floor and the second floor and roof. Okay, so I hope that you enjoy this presentation, and I hope as well, hopefully, you get some help thinking in the way that a structural engineer think. So I see you the next time. I hope that you enjoy this presentation. If you like, make up some subscription to this. Thank you. Bye bye. Then see you next time.